Hi again, this is Chris with How Stuff Works. Today I'm happy to be joined by Brian, the lead project manager for the solar car. Hi Brian, thanks for joining us today.
No problem.
So, this is a solar car. Can you give me sort of an overview? How does a solar car work?
Of course. Well, the first and most obvious thing are the solar panels. So this uses what's called gallium arsenide triple junction cells. Same thing you'd find on the International Space Station or on satellites. Take the solar energy, bring it down into the car, focus it into a DC brushless motor, run the car up to 87 miles an hour for a carbon fiber 625-pound car.
Can you tell me a bit about the motor? It's referred to as the pancake motor?
Yeah, it's a DC brushless motor. It's actually what you'll find in a lot of new hybrid vehicles. Extremely efficient. This model is about 94% efficient.
94%?
Yeah, believe it or not.
Is the pancake motor at all visible here? Or
yeah, if you look right here, you see it. It's only about 2.5 inches thick.
Okay.
And is attached right there to the rear suspension.
The actual power is coming from...
Yep, from this cable right here.
Okay.
Has a peak power output of about 10 kilowatts, which means that this thing could probably put out about maybe 12 horsepower or so.
Okay.
It can cruise at 100 miles an hour on 12 horsepower, believe it or not. Yeah. Most of the power draw for this car, about 70%, is aerodynamics.
Okay.
Only a small amount is rolling drag. We have these extremely low rolling resistance Michelin tires that allow us to keep that drag low. Aerodynamics is the big part. This allows us to go extremely fast and very low power.
And I did notice that there's some awards over there.
Yeah.
What are those? What are those from?
This car was first in North America, third in the world. That was first in North America, third in the world. We had 2 other national champions and 1 other third place finish in the world.
By virtue of the fact that you are traveling, I mean, do you have to account for the fact that the sun is moving while you're designing this car? Is that
I was just going to mention that. So a big part of this is strategy, right? Beginning of the day, the race day, we will be pulling power away from our battery pack to sustain our speed. Middle of the day, we'll be charging that pack back up, making up for what we lost in the beginning of the day. End of the day, we will once again be drawing power away from our battery pack. So it's just because, once again, the power coming from the array is fluctuating as the sun is moving across the horizon over the course of the day. This is a 25-kilogram package of Samsung SDI lithium-ion batteries. So
that sounds like the battery that you have in usually a laptop or something like that?
Yes, exactly the same. The reason why is laptop batteries have extremely high energy density and low weight. Just their power density is perfect for this kind of car.
I'm looking at this and I'm having a difficult time imagining how someone would actually sit here. So how does the person actually place himself into this car?
Extremely good question. Looking down the car here, so that titanium roll bar right there, that's where the driver's head is. And usually you sit up inside the car. In this vehicle, you're actually laying down. The driver's feet are right here behind the battery. So their 2 hands go on those 2 push-pull levers. All of their controls are there. That's throttle, regen, brake, cruise control, turn signals, radio.
Cruise control?
Yeah. Within about 0.1 to 0.2 miles an hour going up and down hills.
In terms of my perspective, so I'm actually in this car and I'm going.
Yeah.
What can I expect to see? What sort of experience would I have as a driver?
Imagine being in a car that weighs just over 3 times your own weight with your eyes only a meter from the ground going at 87 miles an hour.